Hi, my name is Curtis, and I'm Super Sky's project manager detailer for the 2100 pen project. I'm a little late, a little tardy, so I'm trying to catch up as quick as I can. Thank you for everyone's patience. Had an unexpected backlog, which made me a couple of months later than you guys would have liked. To that end, I've been working very hard to get the design where it needs to be very quick. I think I've got it pretty close. I'm to a point where these drawings that I've given the Jordan uh, should help, and I need some feedback before we can move forward in a lot of different aspects of the design. So with that, let's start with the gutter. It's the key part of the whole project is the gutter. Um, this is the original drawing from A494, and it's a simple boxed out gutter. I'm assuming it's about 8 by 12, and that's where we started. I think the main purpose it's trying to convey is low profile, not a very tall gutter. Um, this is what a gutter for a skylight would normally look like, very tall. And the gutters would be below the skylight, and that would give it room to have pitch, a lot of pitch, and then the skylight could weep out at the bottom, and you'd have your grading up here. Obviously, this is not something you want in this project, so it's all about how do we pack this a little bit more compactly, or a lot more. It's a very tweaked design. We have everything kind of cranked in there as best we can. This is what came along with the bid. It's pretty wide. All they really did is take the same basic detail in the middle and add these bars out here to carry the large lights of glass. That's where it started, and then we got some comments back, all of which I agree with. Up here, as a general concept, the air and water tightness, I agree. Typically, our skylights are barrier systems, sealed at the top of the glass, and you can see they're doing that here into the gutter, but there should be something more. And when we get into the other details that we're proposing, you'll see that we do have that. I've also looked to try to move these bars over and get them where you want while still doing this drainage system. And then down here we have the last line of defense. I agree, but I don't want the water to get all the way to the bottom because then it's got nowhere to go but sit there. So we were looking for a way to make any water that gets in drain out as well. And so we've had to work pretty hard to come up with an answer for that. And that's what we're trying to do. So let's go look at what we got for a skylight gutter. We can't drain it at the bottom of the bar like our typical bars. So we've switched to a different system that wasn't shown before, and that's draining. It's got a backup system up here just below the glass. The barrier at the face of the glass is still intact because that's kind of the basis of Super Sky's warranty and everything we build. We don't want water to get in, but we do want a backup system just in case something would fail, and that's what we've detailed here. So we've got the barrier from the glass to the gutter, and then it goes through and back to the glass, and that'll maintain through all the details that barrier. Then underneath, we're trying to collect water in these gutters and then drain it to the rafter, and from the rafter into an inner tray down here. And that's going to be pitched to carry that water to the ends where we can weep it out. It's very complicated because I've got some pitch up here, and then I've got insulation, and then I've got another pitch that's got to be a little bit different to carry any kind of condensate or leakage. Below that, I boxed out the same shape to get pretty close to that 12-inch by 8-inch depth, and then since it was there, I packed it with insulation as well. There's a requirement for thermal. I've tried very hard to keep my exterior metal exterior, interior without touching it. Don't want any thermal bridging where we can avoid it, and then we've added insulation. This is the overall picture of just the spanning gutter. the details get more complicated when you look at how the frame comes in. So we'll go back to this detail, which has the intersecting framing and the connection to the steel. And there's a lot going on. So we have the rafter. You can see it just peeking out here in this notch, if you can see my mouse. And that's where water will come out of there and into this cavity. This seal runs along the horizontals underneath the rafter to make this pocket sealed off. It should be pretty good because there's no downspout. It's just open-ended at the end, so you can't get a plug downspout, which would be the real worry about doing inner and outer gutters. But if we don't have downspouts, there's not a way for the water to back up into it. It just keeps flowing out, so that helps. Structurally, it's difficult to make the rafter, which is 8 inches deep, come over here, be notched on the top, then notched along here, and leave a little tongue sticking over. We've worked with our engineer to reinforce it so that we have enough strength to make this connection, and then a similar connection up at the ridge to get the span for the 12 feet on the right side and the 15 feet on the left. So that's worked out, and we can conceal quite a bit of it with this bottom closure, which we then insulated. It doesn't do anything for water, but once water would get down there and it has to run into the rafters, there's nowhere for it to go. So we just made it an insulation holder and more to keep the sight line of what was seen before. And I think we're pretty close to it. The overall width is 12 and a quarter plus 2 and a quarter, 2 and a quarter. I think it's about 17 inches wide, which is quite a bit less than the 22 and 3/4 that we originally had. So we have tightened it up to get more vision space. Notice that I have the grading up here, and there's a reason for that. So let's look at this one. This is a detail that didn't survive. And we tried to put the grading in here, but we get so much thermal transfer for it, and it blocks the gutter. It just eats up too much real estate to really keep it there, and it's also very tiny. It's not like anybody can really walk on that. And I'm cheating by using a very tiny grate, and this detail just didn't work out. This gutter was the minimum size we calculated, but it just looks too small, so we wanted to make the gutter bigger, and in order to do that and keep the thermal transfer minimized, we had to move the grading. And that's where you see here we've put it across. And this looks kind of clunky, and I'm going to model it, and I will send you an image from the model. I think it will look better in real 3 dimensions than it does on a 2D drawing. But it's about 16, 17 inches wide, so somebody could actually walk on this and not be just crowded into a little tiny 7 or 8 inch wide strip. So that's a big thing to look at, and there'll be more design stuff coming. But by moving the grate, we freed up the thermal, we got the gutter bigger, and those were all things we were trying to achieve. We've got our attachments below. We've set an elevation for where the bearing surface for the steel should be. I'm not entirely clear where the top of the truss is, but I know where this is, 212.25 feet. It could be a channel, it could be a plate. It does need to be wide. We have it 9 inches wide to give a bearing surface to take all that load in from these big lights of glass. It can't be real skinny. It's just too... It doesn't give the engineer enough to plant this thing on. And then we want some room for it to shift left and right, because there will be left-right tolerance in the truss. If we try to make it too tight, these supports will end up overhanging, because the skylight is locked in by the pre-made glass. You can't cut the glass to suit. So if the truss has a little bit of variation, which it will, a little width here keeps it from looking misaligned. We didn't try to design what these are. We just put a surface here, and we need some thickness for tapping. This is all written on some notes in the drawing, so it's not like you have to memorize it here. Originally, I think the tie-offs were coming through the gutter, but that would block the water flow, so we think they should go to the ridge. And I've got that detail here. This is the sloping rafter member. Here's the ridge detail, and here's the ridge detail with the tie-off. We looked at the tie-off submittal, and I tried to take a good guess at what might work for them, and then we will make aluminum covers to sleeve over it. And we thought, so long as we have this closure here, let's go back one. So that's the closure. It mimics the one at the curb. It's a little bit narrower. I think we're about 14 inches wide here. And then that's insulated as well. This is our secondary layer of metal to carry water into this gutter, so this is just insulating space. So if we go back here, this steel is going to be a thermal bridge right in. So it's been my experience that design teams want us to isolate it and insulate it so that it can't frost up or condensate if there's moisture in the building. So it may get cold, but if we keep it isolated, it won't have anything to turn to liquid. So that's what I was trying to detail here. There's some concern about the welding, to weld this top piece to the structural part. I don't think they should weld these before the skylight goes in, as if it shifts, the flashings won't fit, and in order to build tolerance into the flashing, we'll have to increase the sight lines. So it gets to be where, yeah, you can do it, but then the sight line's going to have to suffer to build in the adjustment. Right now I've got it pretty tight, and I thought that was the main attribute to go for. So give that some thought. We can talk about it. I don't think it would be too bad if, as the frames were going in, if the iron workers could come and weld some of this stuff down. They'll have the skylight to work off of, and they can throw a blanket over the skylight frame before they weld so nothing gets splattered. Then it'll be right where it needs to go, and things should go together pretty nicely. This would be at the west wall, and it's really just a first draft. We have the curtain wall system over here, and then we have the skylight. The tube down below, the steel tube, that was lowered to make clearance with the truss. So now we have to post up about 18 inches in some cases. So there's a pretty big gap, and that has to carry a lot of load. That's like an 800-pound piece of glass with a rafter spanning 15 feet. So it needs a good sized connection. That connection may clash with the curtain wall connections because they mounted to the top of the steel. That's noted in here. It would be great if the curtain wall connection could move to the faces of the steel, and then we could go off the top. Otherwise, we'd have to go to the inside surface, and I think that would not look so good. But again, it's the first draft. This piece is meant to really just build kind of a wall there, because the skylight's moving, and we've got a panel that has to go in this height here, will vary as the skylight drops down. We've set it at the same pitch as the glass elsewhere, so that everything is a match. And then when it gets here, this vertical height will adjust as it radiuses around. And then we were going to come over the top. I think, because this is probably a rain screen, there needs to be a piece of rubber that would go from here and maybe down into here. That's to be worked out, but that would be flexible so that this frame can move left and right, and this one can move up and down without them being tied together. And then we just have to figure out how to support that coping. I don't know if an angle can go out here and turn down and then get attached. He might be fixed vertically, which would be great, because then we just have to let it slide that way. And then the coping can't really go anywhere. It's just got to be a sliding joint. And water may blow in and up here, but it can't get into the building. It's either on the outside of the rain screen or it's on the outside of our barrier. And that's the thing. You got to take the skylight barrier and bring it to the rain screen and the curtain wall. Always a little bit tricky to pull off. So, and then we're going to insulate up here. We've got it backed up. That's into the gutter to drain. That's our support. Conceptually, that's what we would like to do. It'll take some coordination, but that's what we're at for this one. This is along grid line C and grid line E, detail 10 on A and 494. It was detailed a little different with the rafter right above the ephes wall, and we think it should move over here so that the wall can be brought up and then this flashing go over the top. That would allow us to take this flashing, and as it comes down on the pitch, it can work into the skylight, into the gutter, which will make a nice clean transition, and then you're always countered over the top of the ephes. Obviously there's things in here that have to be detailed. This is really just a placeholder. I have questions about where this tube is relative to the grid. Is this stud a 6-inch or an 8-inch? It's a little confusing to look at the contract drawings, so I have a lot of questions about that. Again, the elevation of this is either 212.08 or 212 1 5/8, depending if I measure the steel model. These are the surfaces to support the skylight at the ridge, up here dashed in, and at the curb. You'd want to take the curb one a little further so that it can support the liner. This is relative heights of the skylight. This flashing is again going to be part of that barrier, and so we want to keep it in plane, and that will be more clear when we get to this page. This is the east wall of the skylight, which isn't detailed anywhere, and I've just roughed it out. 6-inch stud, 8-inch. The tube I know, but where this guy is I'm not so sure. But we want to make sure that this flashing cover stays in plane with the glass, so that as it bends around and curves and morphs into the end rafter, because I'm always in plane with the glass, we'll be able to make that transition and have it look nice. If we do something not in the plane of the glass, there will be steps and jogs in the metal which won't look smooth and real clean. So this elevation will vary as the run of the rafter changes. But I think this is a general idea of what the detail should look like, and this one works with grid C and E so that you can go around the three sides and cap it off nice and neat. That's something to look at as we go. This is a first step just to get a conversation going. I'm doing the same support post here. It's not as tall, but we'll be consistent from one side to the other. So that's where I'm at with the skylight. There's a lot to look at and make sure we're okay before we get too far down the road. And that's a little tiny plan view. Cross section here, you can see the header on the west wall, and then this coping is going to come and get closer and closer to the gutter, so you can kind of picture this bar going down the hill as it gets close to the gutter, and then that's the vertical height difference in the Super Sky panel that goes underneath the coping. There's a lot going on that side. And then this is the plan. This is the area that we checked for the gutter. It's a tiny bit more area here. We could check that as well. I thought this was pretty representational of what the gutter needs to do. This side is a little bit longer run but less area, so that's what I picked. We can rerun numbers if somebody wants to check something else. So thank you. I hope you can look. I'm sure we'll be talking some more, and this was just meant to help catch up. I'm behind. I want to catch up. I've been working on the details pretty hard. A lot of peer review within Super Sky. We're pretty happy with the gutter detail. It's clean, it's small, it drains. It's a nice detail. I hope you guys think the same so we can keep going, and I look forward to talking with you. Thank you.